Okay, so when someone downloads the app as a first time user, they're going to be greeted with a nice little introduction menu. Now we can customize this to teach them whatever we think is needed, but the idea is I want the complicated menu to make perfect sense and also explain what everything is. So very basically, this is the firmament tracking menu. It explains the sun, how there'll be a horizontal angle of elevation for the moon as well, the angle of your compass, and they can click next to walk through that. They can skip it as well completely. And they can adjust this stuff as well. So right now it's saying latitude is your measurement. If they want to like slide that and test, you'll see how the screen is actually moving. It's grayed out right now because it's trying to focus on that. But it's an interactive tutorial where we'll make sure whoever downloads the app knows how to use it. It walks you through all the menus, how to use it, all the time slider, how to go towards different days, how to use the joysticks at the bottom. And then now we are in the app. So I'm going to enable two buttons up at the top just so I will be auto focused on our guy. So right now we are in some random location. I'm going to use the GPS feature to go to Belize because that's where I am. And you can see my little guy right down there. You can actually see the planets in the background as well on the left side. You'll see two planets. And as I move the time slider, see how they disappear within our perspective. Let me go back out just so I can show you this. So this is our dome vision spherical view perspective. That's extremely important, and it's now modeled out perfectly so that see that yellow line? That yellow line will disappear or appear whenever we're supposed to see the sun. And then it'll disappear as well. So ignore the moon. The moon is not set up yet. I only finished the sun, but the sun works perfectly. So I can check the time, see when 5:47 in the morning is when the sun will just start to peak above the horizon. And that is true. Now, for our model, it also has that first person view. So now that I'm in first person, I can see, okay, cool. So now I can adjust the time and kind of see in real life where is the sun gonna be. So I know at about 6:30 it'll be 10 degrees from my horizon, and I can point my compass 89 degrees east. And this is accurate. So this is what software such as Stellarium will give you, this kind of first person view, and this is accurate. So this combines my favorite part of astronomy, being able to kind of see where will the sun or moon be, also with the bird's eye view flat earth model where we have that. Oh, sorry, I have to unfocus and now select the view and then zoom out where we get the bird's eye view as well, so we can see what actually happens in real life as the sun travels across. And it's really, really cool. So you have all these different views and you can kind of do whatever you want. You can even set the observer to different locations. So let me go over Sudan and turn on the location menu. Let me type Sudan and see if it comes up. No, it didn't. Sudan? Let's just go to Haiti as an example and then focus back on our observer. So now oh, it did come up. It just took a few seconds. So the idea is this is part of the free plan. So anyone who wants to use these features like a location lookup will have it part of the free plan. So that's why it might take a second or so to look up, because we're not using premium top quality instant responses. It's limited to about one lookup a second, but it works. So you can see now how we're in Sudan. And if you also see over there on the left-hand side, how it says Sudan in the left menu, let me move like the latitude up to Egypt. Can I do that gently? Okay, so see how I'm now, my latitude's in Egypt, and the model knows that I'm in Egypt on the flat earth map. It's not actually based on what I typed in. So I want to clarify that the map is actually accurate. So as you move around, like let me adjust the longitude maybe to a different area, and then let me get a different angle so I can see that better. So this right here, how the grid kind of cut out, I still got to work on some of the graphic rendering, but it's really, really good for most stuff. But you can see right here how we're in India and it's correct. Let me focus back up on the observer and let's try a place like Toronto in Canada. Yep. So it took us right there, and these observations will be accurate. So let me zoom out and then turn off the location, turn on the date menu so we can now kind of slide that around. So you see the sun's orbit? One very important thing to kind of emphasize what I'm talking about, let me put the sun where it's just about visible. So see right here how it's visible? And let me toggle off the top focus so that I can zoom up to what I want to show. So the sun is visible right now, but let's turn off the date, turn on the location so that we're only changing latitude. Watch what happens as we go forward. So see how it disappears now? So as we go forward, it'll rise within our perspective. And as we go out, it disappears, even though the time never changed. I can turn on both just so you believe me. I don't want to clog up the screen with all that. But see where the observer is? See where that observer is right there in Canada. And as we go closer to the North Pole, it rises in elevation. So you can actually see in the top left of the screen where it says sun 3 degrees. The sun's at 3 degrees right now from our horizon. But as we lower our latitude, it's now at 1 degree. And as we get closer to the Tropic of Cancer, it's now completely out of our perspective. So this models your perspective perfectly. Let's go right back to the North Pole just so I can also show another really cool thing. So see right now how the flat earth model shows and predicts that the sun is 3 degrees from the horizon. Let's just go a month forward. We're now in October, so it's below the horizon. So that would mean there is 24 hours of darkness now at the North Pole, and there still is, and there still is, and there still is, there still is. Now we're in April. So April 2025, we now have sun at the North Pole. And it'll be like that for a full period of 24 hours. I'm assuming, but let's just check. Yeah. So see now it stays completely above there for 24 hours. And it's 10 degrees from the horizon. And you can go into the first person mode to verify that what we're saying is accurate. And you might have also seen that there's planets here and stars, and these are also accurate. What we'll have is where you can click on them to kind of get more information. So when this is released October 1st, you'll be able to click on the planet, see what it is, more detail about it, and focus on it with your P1000 camera and your nice telescope. You can see the inner solar system, the real celestial bodies in real life. And I think that's really cool. So let's zoom out and let's just cycle through the months so you can kind of see what the sun does. So see the sun's orbit? Actually, I guess it's probably better if I zoom up on it over here. So see how the sun's orbit, it goes between the tropics of Cancer and Capricorn. When it's over the equator, that's when the equinox is. So like September 20th would be about the equinox, and it'd be over the equator if I was to look down on it properly. Yeah. Now, let's also just go to Union Glacier Camp in Antarctica. Union Glacier Camp. Let's turn off the location. Let's focus on the observer again. And you can... What? Oh, no, we want to go to December. Sorry, so December 20th, I think. So see how I'm just quickly changing the dates using the interface? It's really, really nice and convenient. And we can see how the sun is within our perspective. It's 34 degrees from the horizon. Can we get close up? I want to see the different angles. So see that? You can see how we will be looking at the firmament as well for this to happen. And let's cycle through a period of 24 hours. So see how the sun is constantly visible? But as we change months, it won't be. So now we're in March. It's no longer visible. Well, actually, it's partly visible. So you can kind of see where the sun rises and sets in Antarctica at the different times. So let's zoom up on that. So that's what's so cool about being able to model this in 3D, is that we can confirm our hypotheses and test them. What does the flat Earth model predict, and how accurate is that to real life? So look at that right there. That's so cool. And then that should stay there all the way around till over there. So let's see. Yeah, that's so cool. And remember, even though if it's at like a 0 from the horizon, we can't actually see it till it's right up. So this line is actually accurate, that yellow dot where it's showing when we should and should not be able to see it. That is accurate. So I think that's so cool. One other thing is the moon map event. So let me switch over to the bird's eye view, and I guess let's just plot a map. So let's do the first moon map event. So see here, this is the June 22nd event, and we can go right up onto these locations in a flat Earth map. Now, no mapping software lets you do this. Google Maps, Bing Maps, they don't want you to do this, or they don't want you to know the Earth is flat. But it's really, really cool that we can plot these moon events. Let's do the next one, June 29th. So see here on the map, and we can go back in time as well. So if we wanted to then set the flat Earth model to June 29th, we can study this, analyze what we saw, even add new locations. So you can plot new locations